Let us consider a block of given mass which is at rest at the rough surface with given friction coefficients. At some moment, the external force F at given direction pushes the block, and the problem is to find acceleration of the block. The real example, which can be described by this setting, you can see on these pictures. One of my students, her name was John, suggested the following solution of the problem. She considered the scenario when block moves along the surface and analyzed the forces on the block. They are gravitational force, normal force, and force of kinetic friction, which is opposite to direction of motion. This force is given by this equation, so it is equal to coefficient of kinetic friction times magnitude of the normal force. And then John considered a free body diagram, which is shown here. And first, what she did, she decomposed external force into two components. One component along x-axis, magnitude of this component is given by this equation, and the next component, y component, points down, and for this reason it is equal negative f cosine alpha from this triangle. Then she arranged the following table for all forces and acceleration. In the next row, she included in the table x components of all vectors presented here. So for force F, gravity and normal force, they are normal to x-axis, so their components equal 0, and kinetic friction is here, and acceleration. In the next row, she collected y components of the same vectors. This is very important table, and it makes simple further calculations. John wrote the second Newton's law equations in components for x-axis and for y-axis. Look, second Newton law was done by the Isaac Newton, which was born approximately 400 years ago. Until now, we use his laws. Next, she took the components from this row and plugged in them into first equation and obtained first equation of motion along x-axis. Obviously, the next step is to do the same for the second row, which represents y components, and we have equation in this form. Inspecting these two equations, we see that they contain two unknowns. One is magnitude of the normal force and magnitude of acceleration. In the second equation, we have only one unknown, namely normal force, so we can immediately find this normal force in this form. Then we plug in this normal force to the first equation, and we will find acceleration of the block. And now, in the last equation, all quantities but acceleration are given, Here they are. And using these values, John found the final answer, which is A equal 1.69 meter per second square. Everything is great, all calculations are correct. Nevertheless, the solution of John is not right. And the reason for this, I encourage you to find yourself. As a hint, I would like to say that the main mistake was done at the very beginning when John analyzed the possible scenarios of motion. She selected one, and probably she overlooked others, which take place in our specific case. So, where is the mistake? Think about this and help John to find the mistake in analysis of the problem. If you would like to compare your solution with my solution, you can find my solution in the special video, and the link to that video is posted at the pinned comment to this video and in the description for this video. Also in the description you can find the links to the help resources.